Lake County as well.
Save the best for last.
Thank you very much, Michael. Thank you for inviting me over to speak. And thank you for coming along today. We have had some fantastic cakes already. And I always thought that was the reason we had baggy bee suits. We are fond of those in the beekeeping community. We're going to talk to you today about the long-term permanent final solution to Varroa. And it is a bee-led one. This is, just by way of background, this is us, Western Beekeepers. We are just, this is our area here in the Kent and Surrey borders, thankfully quite close to Gatwick, which was useful yesterday. We have about 130 colonies in the project now, and this is just coming into our 8th season. We do nothing unusual, okay, so this is just managed beekeeping, no gimmicks or anything, nothing particularly natural about it. The area is probably not untypical of what you have around here, quite rural, with some houses and some towns, and a few feral colonies. Not as many as we liked, but we keep an eye on those. But the thing that we do is select for Varroa-resistant traits. So these are the traits which are found in colonies which have naturally survived Varroa, which there are an awful lot of them now. And the scientists have been looking at these, the USDA in the States did an awful lot of work as well. So all we've done is copy what those bees are doing and put that into our beekeeping. This is a website we set up last year, so I'd encourage you to have a look at that. It's a non-commercial website. It's got all the science, background science behind these traits. It was led by Professor Stephen Martin and a bunch of us beekeepers working together. And on there's case studies of around the UK, including a couple of commercial beekeepers, Foragers Bee and Honey Company and Fen Apiaries. And the biggest area in North West Wales of resistance, Varroa resistance, in the UK and probably in Europe, where they have about 500 colonies under management. And they've just celebrated their 16th year of not treating. So a lot of widespread Varroa-resistant traits. If you add to that all the beekeepers which have not treated for at least 8 years, you can see there's a real spread of Varroa-resistant traits. And that will underestimate the amount of beekeepers in the UK who are already there. And I would think in Ireland you'll have exactly the same. We just haven't known how to recognise these traits. So the presentation today, we're going to talk about where we are currently in the treatment trap, which is perpetuating the Varroa problem. We'll talk about the mechanisms the bees are deploying, how to get started with the monitoring, how we do it. It's very straightforward. Some of our own case studies, we've done quite a bit of our own research on this rather than just rely on scientific research papers. How to produce Varroa-resistant bees, just how we're doing it. You might just strike some chords with it. I appreciate there's a lot of beekeeping expertise already in the room, so there might be a bit of sucking of eggs on that, but how to work as a club, which has really been beneficial for us, and others have started club projects as well, and some lessons learned, things that we didn't get right or learned as we went along, which we hopefully can shortcut your own experiences. If you have any pressing questions, shoot your hand up and we'll try and take them as we go. And then we'll have a main Q&A at the end. Yes, sir?
I'm not an expert by a long shot. What is the Varroa? Is it a bee?
Okay, so it's the Varroa mite is a small little mite, dark reddish brownish mite, and we'll see some pictures of it. And it's come over gradually across continental Europe into the UK and Ireland, throughout North America, South Africa, and it's from Asia, and it's been destroying our colonies in the UK for just over 32 years now, and I think in Ireland about 28 years or something like that, so over a quarter of a century. And we're going to talk about, and we've been deploying chemical miticide treatments to try and kill these mites, and for a long time, and we're going to now talk to you about the final solution to this Varroa problem, which is what the bees are sorting out. Okay. Right, so the treatment trap. So this is currently where we are at the moment. We're in this cycle of not being able to select for Varroa resistance. We just haven't understood what to do, how to do it. And because of that, we produce bees which are susceptible to Varroa. They need treatments or biotechnical measures to reduce those Varroa mites to keep those bees alive. And then we breed from those bees. Their drones fly, we increase from them, we might graft from them. So we're breeding from bees with low defences to mites. The other thing that happens is that we never kill all of the Varroa through these treatments. There might be 10% surviving, there might be 20%, but they are surviving all your efforts to kill them, and they are the new breeding stock for Varroa. So in effect, what we're doing is breeding for bees with low Varroa defences, and we're making the mites more resilient. And that's why we still have a Varroa problem today. If you go to places like communist Cuba, where they just dictated they'd stop treating, or South Africa, where they gave up treating very quickly because they couldn't control where all the bees were, there was widespread Varroa resistance in 5 to 8 years. So that's how quickly natural selection can sort it out if you completely back off. Now, we chose not to do that in Ireland, UK and other places, because we didn't want the losses, which is understandable. But here we are over a quarter of a century later, and we've still got the problem. And the problem is because of this cycle we're in. If you start selecting for Varroa resistance, which is what we're going to talk about today, you then get resistant bees. They don't need treatment to keep them alive. You're then spreading resistant traits, the drones from your increases, from grafting, and then you have a low level of mites. And there's your solution. Right, so Varroa resistant mechanisms by the bees that we're going to be looking for. But just before we get into that, this is our definition of Varroa resistance. There's a few what we call slightly flakier versions around. This is where we are not involved as beekeepers in any way in managing the mite population. There's no treatments, there's no drone culling, there's no sugar dusting, there's nothing that we know, bee gyms, they pop around occasionally. So this is, the mite population is handled by the bees only. And the solution has to be in worker brood. And why is that? So when Varroa was in Asia, it was only able to breed in drone brood. And if we had them breeding just in drone brood here, we wouldn't have a problem. So this is for one of my hives, the amount of worker brood, frames with worker brood on. There's a swarm here, an artificial swarm. So there's worker brood from January right through to November, but the drone brood is a lot more seasonal. So because when the Varroa came over, there was no defences to Varroa, they were able to breed in that worker brood. So they couldn't believe their luck, really. You know, in Asia, there's this balance between the host and parasite, because they're only in the drone brood, but over here, they were able to produce a huge amount more mites. And in effect, they were killing the colonies, which they don't want as a parasite. They don't realise that. But as a parasite, there should be that equilibrium. So the battleground for the solution to Varroa has to be in worker brood. We all comfortable with that? So there are 3 phases to Varroa resistance. The first is the search process, where the bees are looking for Varroa families and for parasitized pupae in the worker brood. The second phase is the interruption of Varroa reproduction, and that involves some pupal removal, and we're going to see some examples of that. And the two of those things together give you low levels of mites and deformed wing virus. So it's the deformed wing virus which is vectored by the mites, which reduces the longevity of these bees. So low levels of mites gives low levels of deformed wing virus. Yes, sir?
Just a quick question. The deformed wing virus, is that evidence that there was mites in the cell of that bee that caused the deformed wing virus, or can it be spread to other cells which the mites weren't in?
Yeah. So deformed wing virus is everywhere. It's in lots of different types of insects, and it was always in the honeybees as well, but at a very low level, and just passed around colonies without any impact. So we never really understood it. because it was never something that got commercially funded for research. There was no problem. But when the problem with Varroa is it is able to vector the virus straight into a larva or a pupae when it's feeding. And in doing so, the virus explodes and then it becomes a problem. So normally when it's passed around through feeding or through cleaning the virus, it's just dealt with by the immune system of the bee. So it's not an issue. So it's not a question of whether it's out there or not, it's a question of the load of it.
So more likely than not, that bee that has deformed wing virus, there was mites in the same cell
Yeah.
as it was developing.
Absolutely, but they can have it at a really low level. In the same way in this room, there's tons of viruses, unfortunately, you know, but most of it would just be handled by us and not an issue at all. So another question, let me move on. So, I hope this is something you've probably seen. We certainly, when we found out about this, we thought we've been seeing this for years and have never appreciated it. So the search part is finding the bees open up these cells at the pink to purple-eyed stage. And we used to be known as bold brood, and if you'd asked any of the experts in bee health what that was, they said, well, we're really not quite sure, but you should requeen. In fact, that's the worst thing you should have done, with the benefit of hindsight. So what happens is that the surface of the cell, the worker cells, is microporous. So bees are tapping the surface and touching it all the time to check for temperature, check for CO2, humidity, and they can also check for the health of the larvae and pupa inside. So the uncapping is taking place at the pink to purple-eyed stage, and that's important, okay? So when you get the chance, when it warms up, it's going to warm up next week, isn't it? Yay! Yeah. When you get the chance to go in, have a look for uncapping and look for the eyes, okay? So they open up the cell to investigate further, and it's usually in a cluster, so there's a few of them here. And what's happening is that this chemical cue that there's a problem inside this cell is coming up through the cell and being wafted around by bees. So there's a level of inaccuracy. So there's usually a cluster of cells which are opened up, of which there might only be one or two which are infested, and then they get recapped. So there's a bunch of bees which we didn't know about who just do recapping or capping of cells. So it could be you guys in the front row here. That's your job, you're cappers. You don't have a brilliant sense of smell, but you're really good at capping and producing microporous cells to put on these. And if you come across a cell like this which is uncapped, and it's healthy and alive, you're going to cap it, all right? Because that's what you do. And there's a record from where scientists look at the capping and uncapping going on in an observation hive of the same cell 17 times. The same cell. So this is going on in all our hives. We had no idea. And we'll show you a little bit of evidence of that a bit later in the presentation. So this is a search phase. This one here, they've chewed off the top, and you can see the cocoon, larval cocoon there. So they're going to dive in a bit further. I suspect if we went in the following day, that would be uncapped. The second part of the process is the chewing out of infected pupae. So here it is at the purple-eyed stage again. This is a still from a video, and they were busy chewing that out. And we'll show you why that matters, okay? But we were having a chat beforehand with someone who couldn't stay. This is a classic looking bit of comb for us. See, there's a bit of uncapping there. There's quite a few what we call pop holes, which they weren't filled in the first place, or they've had removals by the bees, which to us is a really healthy sign. But if you look at all the marketing of a perfect brood frame that gets held up, every brood cell is sealed. And to us, that is mite breeding. Those are bees with very low hygienic defences, and you really don't want those in your apiary. So quite a few pop holes, and you can see there's a little bit of uncapping in different places there, and some chewing out going on. And the chewing out, we have the opportunity to be able to monitor very simply, and we'll get to that. This was a bit of the science behind understanding that by Professor Fanny Mondet in France. They do a lot of good work there. And they did some tests, laboratory tests, and where they tested the proportion of uncapped cells using different things. So the first one we've highlighted here is dead pupae. Dead or injured pupae in a cell, they'll uncap it almost 90% of the time. So they'll know that. They'll know there's a problem. They'll know there's a hygienic issue. And the other really interesting, the big find, was that they'll also uncap almost 80% or over 70% of the time if there's offspring of Varroa. So they know the scent of Varroa. Interesting. Well done, the scientists, because we would never have worked that out, but they did. And here's another interesting. If you just put a female single Varroa in there, they hardly bother uncapping it at all. So a single female mother without Varroa, without offspring, is uncapped only about 10% of the time. So interesting bit of science. So let's have a look at this in practice. So this is the 12 days of the worker cell is sealed. So there it's sealed at the top. Then the larvae starts spinning its cocoon, and stretches out, becomes the pupa here, and then we get to the pink eyes, purple eyes, which is going to be key, and then we get a bit of colour on it, and then wings, and then it hatches out imago after about 12 days. We all sort of know roughly that's how it works. And this is how the mother mite tries to reproduce in those 12 days. So she pops in up to a couple of days before, and she hides in the larval food. You know that juicy white larval food at the bottom of the cell? So she's in there, upside down, with her peritremes coming up like snorkels, trying to breathe. And then as soon as it's sealed, she creates a feeding hole on the larvae, and her oogenesis, her egg-laying cycle, kicks in. And her cycle of laying is she lays a son first, this is every time, and then a series of daughters in roughly this sort of timing. And the blue line there indicates when that son is sexually mature enough to mate with his sisters. This is not pre-lunch discussion really, is it? But it is pretty cool stuff for the Varroa, hey? They don't muck around, they've come a long way and they found a way to reproduce. And so that's how it works in Varroa world, okay? But what's happening is that the bees are interrupting at the pink to purple eye stage. So before the son and the daughters get together, because they're not getting together here until about day 10, before they can reproduce, the interruption has taken place. Right? And pupil is taken out, and all of these immature offspring will die. Good result for the bee. The mother mite will usually escape, but she has limited reproduction capacity. She can mate 2 to 3 times. Right? So after 2 to 3 times, she becomes infertile. So in naturally NVR, naturally Varroa-resistant colonies, about 45% of all of the mother mites are infertile through this interruption process. So not only is it wiping out the immediate increase in Varroa, but you're stopping the future increase as well. So you don't get this massive growth in Varroa that everyone fears, and why we've been treating for a quarter of a century or so. You get this sort of bobbling along effect because of this interruption. Let me just go back to this slide. This is the slide I'd like you to read. There's 2 slides I'd really like to remember. It's this one. When you see uncapping, think of that timing of that interruption at the pink to purple-eyed stage. So let's have a look at this in terms of a diagram. This is a bit oversimplistic, so I apologise for that, but just run with it. So these are Varroa susceptible bees. These are bees that we've been breeding for a long time now, and you can pay quite a lot of money for these bees. And so here's your mother mite. She's going to go in. She's going to try and produce a number of offspring. The average she produces is about 1.5, right? But we're going to assume that she has 2 daughters, okay? Because otherwise the maths are appalling. And so it's a slight exaggeration of numbers. You'll just put a pinch of salt in that. So what's happening here is that when she goes in, there's a pupa which has been effectively injected with a little bit of, that's in the book you bought, so it's okay, yeah. There's a little bit of virus injected into the fat bodies of that pupa, which is going to explode and grow very quickly and will reduce the longevity of that bee, probably by as much as 2/3. So you've now got 3 foundress mites mated. They are going to they go in, have another go. They produce 2 each. Again, slight exaggeration, but then you've got 3 pupae which have been affected by deformed wing virus. And there you've got a small army, just in 3 generations, okay? So these are bees you do not want in your apiary. But you've also got a heavy virus load, so even if you are treating, even if you treat it in the spring and then again in August, you're going to have this build-up of mites and deformed wing virus, regardless. And here are our lovely Varroa-resistant bees. And I know there are people here already who have got Varroa-resistant bees. Paddy here, Paddy, and there was someone else as well. There's a few people. Thank you. So you have them in Ireland, okay? And go and form a queue and try and get bees out of them if you can. It's the best way of getting going. So here's your mother mite. She goes in. They sense there's a problem, either Varroa offspring or there's infected pupa. So they chew out that pupa here. There's no offspring because they've all perished. They've sacrificed 1 bee. She has another go. Same thing happens. They chew out that pupa, it's infected, they sacrifice 2 bees, and so until you get to here, she's now an infertile mother mite, so she can't do any more damage, she can't reproduce at all. So for the sacrifice of 3 pupa, you've got a low level of mites compared to these bees, and you've got a low virus load. And that is a simplistic diagram of Varroa resistance in action, and what's happening in a lot of your hives and our hives. So monitoring couldn't be simpler, okay? And so just some ideas. What you're looking for is to find those bees with high defences. Sorry, yes, sir.
So, just we might come back to it again later, but there is a behaviour, of course, which I guess we've all been taught and observed sometimes too as well, where the bees will uncap nearly all of the pupae and throw them out of the hive as a Varroa reaction. How does that tie with what you're talking about here? Is it something completely different, or is it along the same track?
I've seen them uncap a lot,
Yeah.
but then get recapped. So I've not seen them throw out a huge amount. Never seen it. There are some bees which get slightly oversensitive to it, and they will, and that chemical cue that's getting wafted around leads them to over uncap, if you like. But I bet you if you went back the next day, a lot of those would be capped over again.
In this case, I'm talking about them actually throwing the pupa out of the hive nearly too as well. So that's okay.
Never heard of that, and it could be something completely different going on. Yeah. So we're looking for bees with high defences versus bees with low defences, and you can't just monitor once a year, which is what we're currently taught about. We get taught about integrated pest management. Why don't you have a look at your mite levels before you decide whether to treat or not? And then rarely we just go ahead and treat, is usually what happens. So you need to get re-engaged with the Varroa and the honeybee interaction. It's fascinating, okay, but we're going to get back in understanding what's going on rather than becoming experts, as we have done, in understanding when to treat, what time of year to treat, when to have supers on or off, which is, we've become disengaged with what's going on within the hive. So get involved, have a consistent approach, whichever you choose, and then make selections based on that. And that's all we're doing, keeping it very simple. So our monitoring, we use a board, a Varroa insert board under an open mesh floor. So we're of that generation where we got told to buy open mesh floors. And actually now they're incredibly useful because we have a board underneath, so it acts as a quasi floor, and we get a lot of useful information. So I'm a bit fortunate. I have an apiary attached to the garden, so I can get down there every 3 or 4 days and have a look at mite levels, clean the board, have a look. And you're only counting the dark mites. Right? These are the potential foundress mites. The rest are offspring. They're a bit harder to see, but these are immature and they won't be able to mate. So just count the dark ones. There's a club next to us who have their own projects. They do it weekly. And then one of my colleagues in the start of our project, she just puts a board in 3 days a month. And I tell her that's not enough, Topsy. And she says, get lost, Riley. I've only lost one hive in this project. You know, how many of you lost? Okay, so you can take 12 data points and still get information, which is what she's done, and she looks for the other traits as well. Now, the big win of the board is finding chewed out exoskeleton. So when those bees are chewing out the pupa, the first things that come out are the antennae, and then bits of the head and bits of the proboscis. And so you can see that there. See, that's a bit of antennae here, other bits and pieces. It's rarely the full abdomen which tends to get flown away. And sometimes the whole pupa gets flown away. And you see a little small white flag behind a bee just helicoptering out of the apiary. And in the winter, they just throw it outside of the entrance, and either a passing robin takes it or it gets flown away in a milder day. But typically, there'll be bits of exoskeleton coming down. So you get to see the whole process during the open season. You can see uncapping at every inspection is easy, and then you start to see the chewing out process. And you can do this through the winter as well. So winter beekeeping is back. You don't have to, once you've done Christmas, you don't have to give up beekeeping and get itchy about it for 3 months. You can be keeping an eye on what's going on in your hive and really understanding it just by these boards. So this was the board earlier this year, I think it was. So the Varroa board gives you opportunity in a non-invasive way to monitor from January to December, which is what interested us. It's non-invasive. It's quick and easy, 30 seconds a hive, roughly. You don't have to open the hive, so that's great. It's a measure of the mites and activity from the whole colony. And I'm going to contrast that with sampling approach in a minute. You get to see the pupal exoskeleton, which is incredibly useful, understand other aspects of the hygienic behaviour. It's very seasonal, different things going on. But it does need some interpretation, okay, which is part of the re-engagement of the beekeeper and just understanding it. We compared that to sampling, which is what most of the scientists use. They'll take a cup full of bees, 300 bees, or 100 bees, I think Randy Oliver uses, and but you can. That's March to September, you know, just during the open season, or even April to September, depending on your weather. It's a bit more invasive. If you use alcohol, you're going to kill 300 bees a time, which is not everyone's cup of tea. It does involve a little bit of effort, as opposed to, for us, 30 seconds. It's a measure of the mites which are on those 100 or 300 bees, as opposed to a measure from the whole colony. And the whole colony, it includes everything that's going to be in that brood from time to time as well, because that has to hatch. So you might think about whether you need to correct. If you think when there's brood, you're taking a sample of 100 or 300 bees, you might want to correct for the amount of mites which are going to be in that brood, which will be about 80 to 90%. So it's a pretty inaccurate number in our view. But the scientists love it because it gives them a nice percentage. So if they've taken 300 bees and they've got 3 bees on it, they'll just call it 1%. You know, and scientists love that. You know, but for us it's slightly meaningless because you know where most of the mites are. They're not on those bees. You don't get to see the chewed out pupal exoskeleton. You don't understand the seasonality of hygienic behaviour, and again, it needs interpretation, which is fine. That's something that we all have to sort of understand. So we've gone ahead using the Mite boards, and a lot of the other clubs have adopted this as well. So here we are in January of this year, beekeeping. Got rid of all of the family who've been sponging off us over Christmas and New Year, and you just want to get out and do something different. So there you are on your boards. You know there's about 5, 6 frames of bees there. Active, which is good news. I know what the mite drop was over the last month, so nice low mite drop. Also know what it was for last year, so that's a colony I really hope is going to do well over the winter. When I tune in a bit, have a look. I look over the top of my glasses usually, and get your nose in there. There's an egg. Fantastic. I know the queen is laying. I've got a laying queen here on the 7th of January. Excellent. And occasionally you do see a few eggs at the start when the queen kicks off, and I think it's just she might get a bit over enthusiastic, and we get taught that they eat all the eggs for protein, but it seems that they do throw a few out as well. So you know you've got the queen laying. This was even better news. Hive 7 on the 16th of January this year. Can you see that in the middle? Not very easily. A few people at the front nodding away. Let's blow it up. Antennae, proboscis, head, bits of exoskeleton. So 16th of January, I know two things, two really good bits of good news. That 14 days ago, approximately, my queen was laying, because we know this happens at the pink to purple light stage. So 2 weeks earlier, my queen is laying, and secondly, the bees are taking on the early attempts of overwintered Varroa to reproduce. So without that defence, the Varroa are already building, which is why you get this massive build-up of mites in bees, in colonies with low defences to mites. But not in our bees, and not in some of your bees, because already they're taking it on. Good news, huh? We've got to be, January beekeeping is fantastic. You know, it can be worrying as well if you're not seeing this, but it's a great, and there's 16th of January, different hive, bit more exoskeleton, so good early indications that the colonies, and all my colonies are doing this, okay, so it's when they don't do it I get a bit worried, but keep your monitoring simple. Here's my little sheet I just take down, and there's different days along the top. 8 plus 1p for me is 8 mother mites over that period, which is 8 adult mites, 1 juvenile, 8 plus 1. So I count the juveniles as well, because I won't use the word my wife uses, but it's because I'm interested in it. And sometimes you see a huge amount of juvenile mites, you know, particularly towards the autumn. We'll talk about that in a minute. And then the P is for pupal exoskeleton. So I just know what the bees are doing all the time. So I've engaged in the Varroa and the bee interaction. It's simple, very simple monitoring. We also put it into our record cards, so just let me know what's going on with the mites, low, high, is there uncapping, and is this queen a breeder? Does she have the hygienic traits? Do we want to breed from? And this is interesting, that the queens that we have with the Varroa traits pass it on to their daughters and to their granddaughters and so on. So once you find it, just make sure you breed and keep those queen lines in your apiary. That's all we've done. Very, very simple. And we found that with other, I'll come back to you there, we found that with other people we talked to around the UK. It's passed down the queen line, which is just excellent news, yes.
It doesn't affect myself, but in treated hives with acid, has any of that uncapping been seen in them?
Yes. It's there, it's been there for a long time. Because we look back through our own records and we put bold brood scene, you know, and this is what it was. And so it's still there. It's because you'll still get that mite build-up. We just haven't recognised what it was. So the bees have still got that ability to do it, or some of them will have that ability to do it. This is a free download. Oh, sorry. This is a free download on the Western website. So if it's of any use to you, please help yourself. Changes to it. So we just integrated it into our normal beekeeping. So we don't think about Varroa that much now. It's just as much as anything else that we think about. So this is the second slide I'd really like you to take home and think about and remember. And this is the benefits of monitoring. So this goes back a few years now. This is the spring mite drop through these 3 months, coming out of winter into the spring. It's a really good time to monitor for Varroa, the best time. And the scientists will tell you it's the better in the autumn, but there's nothing you can do in the autumn, it's too late. So the spring is a brilliant time for understanding your different colonies and their abilities. And this slide shows the accumulative mites. So not daily drop, but they're just added up as you go. And you can see here, these 4 hives here have a pretty low mite drop, 500 and over those months. And hive 8 here, absolute sinner. You know, no abilities with Varroa. But you just think about what we would have tried to have done with that colony in our old thinking. We would have tried to keep it alive at all costs. You would have thrown formic acid at it, you would have done drone culling, you might have dusted sugar through it. You would have done everything. And when you'd kept it alive, if you'd managed it, you'd have been pleased as punch. And then you would have probably bred from it. The drones would have been flying. You might have done an increase from it. And then you would have taught people about that as well, how to keep a colony alive, which had a lot of Varroa, and you would be incredibly proud. But what you've done is perpetuated the Varroa problem. You've kept those genes going that cannot cope with Varroa. And that's just a simple picture, a chart of why we still have the Varroa problem today. We're keeping the hive aids going. So what would you do with that hive aid, with that knowledge that we have now? What do you think your options are?
Swap out the queen.
Swap out the queen, yeah. Spring, absolutely easy to do in the spring, can't do it in the autumn. Any other thoughts? So, welly boot on the queen, it seems to be the Irish way, okay. Quite right. Well, actually, what we did do, we gave it to some, I'm going to say friends, but people with beekeeper friends, and who live about 20 miles away, and they do full nuclear attack on their bees with no shame. And they actually phoned me up, so we got a whole super of honey out of those bees, Steve. You know, and then they died the following winter, unfortunately. But so they did give some pleasure and some honey, and they didn't do any damage to our sort of quite big breeding area because they're out of area. But requeen is the right answer in the spring. In the autumn, it's more difficult because the new queen doesn't have a chance to take over the hive with their nurse bees and solve the Varroa problem. So in the autumn, you might want to treat or use some of the biotechnical methods if you don't want to use chemical treatments. Keep those bees going to the spring and then requeen. But that's number 2 slide. You've only got 2 slides to remember today, and how good the cakes were. Here's our framework for mites. Again, it's got to be simple, otherwise no one takes any notice and it doesn't work. This is for a national hive, okay, so now everyone will have different hives, different brood box areas, so just prorate it according to what you use. And we look for roughly 5 a day of mite drop over a whole year. So it's never going to be 5 a day every day. It will be 0 some days, 10 another, and so on. So, but 5 a day is the guide, and there's your breeder. Over 10 a day, roughly, that's a requeener, not a hive. You don't want those traits near your other bees. And then that tricky area in the middle, okay, which you're going to have to work out yourself because beekeeping is all about judgment, huh? So you're going to have to decide in which direction you think those mites are going or if they're going down or not, so good luck with that. So here's the wrap up on monitoring. So only 3 things that beekeepers need to do to re-engage and solve the problem. First is look for uncapping. So there's a picture of it. Look for the chewed out pupa exoskeleton, which again we can see, easy to monitor for. That interrupts the Varroa reproductions. You know, that was slide 1 we had to remember. That gives you low level of mites. You don't get this massive build up, okay? You get this bobbing along effect. And with low level of mites, you get low levels of vector deformed wing virus. Okay? Right, these are some case studies from our own research. So we like to do our own work. If you're going to make judgments based on your bees, you want to be sure you understood why you did it rather than some scientists suggested it was a good idea or not. So we did quite a lot of our own work. So here's hive 1. It's the queen excluder there. So they only get a brew box, the queen, that's all she gets. I used to do the thing of trying to give them more space, and you give them more space and then they swarm. You're just extending the time before they swarm trick, and we got found out a few times, oh, hang on a second, if they're going to swarm, let's just let them get on with it and we will artificially swarm them. So we accept that now, and we use the swarming as a great thing for producing queens. So we've tried to sort of work with the bees as much as we can. It was a good year for honey. There's a little bit of insulation on crown board you can't see, and actually on the sides as well. And we're actually moving to more insulation. I think it seems like we're stressing the bees a little bit by putting them into thin wall hives, and the whole idea of that in the first place was just to save money and make it easier for the backs of people who are humping around hives. So for the bees' sake, they prefer something a bit more insulated. We have the Varroa board in all the time. The bees are darkish and have got darker, okay, which is interesting with open mating. And they're pretty well behaved, you know, not always. I call them sort of educational bees, that they'll let you know when you know the type, that you've been in faffing around for too long. We see the uncapping and the chewing out. We have all of the daughters. We know the daughters, the queens and the granddaughters, we know them all because they're all related, because we just hang on to them all. And they produce was going to say the same amount of honey roughly as they used to, but when they were treating, obviously it's very difficult because the weather changes every year, which is the key delta. But we think it's about the same, roughly about the same amount of surplus, so pretty normal bog standard type bees. This is their full analysis of their hygienic behaviour through the course of the year and their daily mite drop, and we've correlated it with the amount of brood along the bottom, which is too much information to take in. So let's just try and break that down. So these are the frames, worker frames with brood in, which have just been recorded straight from the hive record card. We've had to guess a bit out of season, as you can see. And there's an artificial swarm there, so we managed to catch them in time. New queen starts laying very rigorously, and then you get that natural sort of fall away into the winter. So there's your brood, where the opportunity for Varroa is to reproduce. And here's your mite drop.
What's the number on the green? That's not the amount of frames.
It should be the number of frames, yes.
Number of frames.
Yeah. So I have 12 frames in a box. 12 frames, so that was almost full of brood. So this is the mite drop per day, the yellow line. So this was about 4, starts off about 4. And then initially, the mite drop falls. You think, well, this is good, isn't it? But actually, when you've thought about it, there's brood here. So the brood, as the brood starts being laid, the mites should fall because they should be going into the brood, trying to reproduce. So there's a little bit of just interpretation that you just need to sort of think about. When the drones are laid, roughly April-ish onwards for us, there's very much less hygienic behaviour in the drone brood compared to the worker brood. So the Varroa have a fantastic reproductive time with the drones, which helps in the colony. If you think about it, what you want in the spring is a massive amount of spring nectar and pollen to be coming in, and the bees to build up, which is and getting ready for a reproductive swarm. That's what they naturally are trying to do. So the boys are taking the hit here, allowing the workers to get on with the main job. Heroic. I mean, we don't get enough credit, I think, the drones.
Would you ever remove drones?
No.
No.
Because you're interfering there, aren't you? And when you start interfering, you get the wrong results. Because you start taking away the Varroa problem from them, in the same as we are with treating. And then you start breeding from the wrong bees, because you think you've got no problem. So we do the opposite, okay? And so we'll come back to that. And that needs to be a bit brave, and it also needs a complete turnaround of everything we've taught ourselves for the last quarter of a century. So drones, heroic, and mites going up, okay, because there's less hygiene behaviour in the drones. And then they get the swarm event here, and so it goes sort of almost broodless, and we always see a small pickup in the mite drop when there's an artificial brood break or a brood break, and it's because all the mites are forced onto the bees. They've got nowhere to hide. They should be in the brood normally. So, and there might be a little bit of a grooming benefit, but we'll come back to grooming, or they may naturally fall off. So there's always a bit of a blip here. So there's 170 mite drop. So we're able to look at that. Now this is the bit that's quite interesting compared to what we normally talk. So there's 11 frames of brood here now. The new queen is laying like Billy-O, and the Varroa, which have been hanging on to the bees, they're absolute experts at that. They're moving back into the brood because there's 11 frames of brood here. So the mite drop falls. But this is the time we're normally taught in mainstream beekeeping to check your mite levels. You're going to be nowhere with that. You're going to have a false reading every time. So you just need to have re-engaged and understood that. So the Varroa, so the mite drops are falling, but you know where they are, okay? They're having a go at reproducing back down here. Then we get to this beautiful thing, which is a 661 mite drop. Wow. Now, when we first came across that, I'm in your way there. When we first came across that, it frightened the bejesus out of us, because we had no idea, we weren't ready for it. None of the scientists had done this research, and we didn't understand it. So we had to work pretty hard to figure it out. So if you have any other ideas behind it, do come up, because it's useful to hear other people's interpretations. So this is ours. So we see this in every colony. Right? There's a spike at the end of the summer. And you see it correlates with this fall away in brood. So it's gone down from 8, the start of 8 frames of brood, down to about 3 frames in October, 4 frames in September. And the initial cause is this build-up. During the strong summer flow, there's a big build-up of mites. And the reason for that is that the strong summer flow causes less hygienic behaviour to occur, because all of the activity in that colony is in honey factory mode. It's their winter stores that are coming through the front door. You see it as your honey surplus, they see it as their winter stores, and everything is subordinated into turning that nectar into honey and putting it upstairs. And they keep finding another empty space above the last one they filled up, and they keep foraging like mad, and they do a lot less hygienic behaviour. And we know that because we monitor the hygienic behaviour. So there's a build-up of Varroa, which has happened in the months before. Then there's this reduction of cells. So all of a sudden, there's less cells for the Varroa to go into, and there can be 2 or 3 mites, mother mites, trying to reproduce in the same cells. Now these amounts of mites and offspring in the same cells are a piece of cake for the detector bees and the sniffer bees to find them. So we see a huge amount of chewing out at this point in time on those bottom boards. And then we get something else, which some people who like producing lots of honey are going to feel slightly uncomfortable about. And it's, we call it a pre-winter hygiene behaviour. We learnt it from Torben Schiffer, who's like a German version of Tom Seeley. And he calls it stores secure, that when a colony has sufficient stores for winter, it then focuses back in on the brood nest, getting that brood nest ready for the winter. You know, the moment when you go into and do an inspection and you're picking up a frame, it won't come and it's dripping with propolis. You know, that's when the psychology has really moved on to getting ready for winter. And they also do a huge amount of hygienic behaviour, which we think is tied in with this mite drop here. Now, if you take all of their honey off, just by way of an extreme example, and I'm sure no one does that. No, I'm sure no one does that. If you took all their honey off and gave them nothing, they would then, you'd stress that colony into starting off to try and forage everything it could. So the whole activity would go back into trying getting winter stores in, yeah? And because they'd do that, they'd have to process those stores and turn it into honey, and there'd be hardly any hygienic behaviour. So one of the things we do is to leave a full super of honey on those colonies. So they have a brew box, no queening through it, and when they look upstairs, the larder is full, and they see that they have enough winter stores. So let's have a look at this peak. We did a bit more quantitative work on this peak of mite drop. So this was a brood frame from last winter. It was actually from a nuke, but it's pretty typical of what we see in the late summer. So all this is worker brood here. It's starting to, backfilling it a bit here with as we're into the autumn. And in that area, that yellow area there, there's 1,100 brood cells. And then on the other side, we're assuming there's 1,100 brood cells as well. So just over 2,200 brood cells, worker brood, per frame. And then in September we had about 5 frames of bees, which give you 11,000 bees. These are your winter bees, okay? They're going to get you through to the spring. You've got in October roughly 3 frames of bees, giving you 6,000, over 6,000, and then say we're going to assume 1 frame of bees in November for just over 2. So you've got just under 20,000 winter bees, which are crucial to getting you through to the next spring, and they need to be healthy. And you've got a mite drop of 661. No problem, huh? Okay, so we've got away from this fear thing that we're, you know, if you don't treat, they're all going to die. If you saw 661 mite drop, you would have thought someone's treated those for you, or you would have thought those bees aren't going to survive her. But when you rationally work it out, they can do that. And let me just go back a couple of slides. since publishing the book, there's a guy who wrote to me from the Netherlands, and all he does is count mites at this time of the year. He says the ones which have the lowest mites at this time of the year have managed them all year already, and those are going to be my breeders for next year. So all he does is count mites for a couple of months. He picks up the size of the spike here, and those are his breeding stock, and that's working for him, which is interesting. Oops. Yes, sir.
Like by insulating the hive too much, are you not, you know, you're shortening that brood break?
What do you mean by that?
I mean, like for them to do their hygiene and that, there's less brood for them. Like, you know, the pupae and everything's gone down. Like by insulating like that period of time, the shortest day. You know, have the brood as little as possible that they can manage it.
Yeah. So brood breaks.
By insulating it too much, you're leaving bigger brood that they would have naturally.
Yeah, I mean, let me just answer a slightly separate, different question. Okay, so brood breaks have very little to do with Varroa resistance. Okay, so that's partly, I think, what you're asking. So one of our best colonies, which had fantastic amount of hygienic behaviour, maybe too much, had no brood, had no artificial swarm that year, but it had hard-daily mites in the colony. Right, so it's all about the ability of the bees, the antennae, and the uncapping and the chewing out. That's the key to it. And the way to think about it is, we've always had brood breaks. You know, before we had Varroa, there was always brood breaks there, and then after Varroa, we still had brood breaks, but we had colony losses because the bees couldn't cope with this build-up from January right through to November because they didn't have this ability. But now they do have. So the brood breaks have been a constant, if you like, and they're really not the key to Varroa. And a lot of people get that wrong, and you see it being passed around in Facebook forums and other places. It's not the answer to Varroa at all. The reason we've gone for a bit more insulation is a guy called Derek Mitchell, who comes around. He's an absolute physics geek and understands the whole thermoregulation and science behind insulation. Now, and a lot of it goes straight over our heads, but the really simple point is that bees naturally go for and have got used to being in a very well thermalized environment. So in a cavity in a building or a tree, if the outside temperature is doing this in the winter, inside that cavity it's only doing that. So that's all they have to manage. So we actually stress them by putting them into a thin wall hive. So we're just trying to correct for that a little bit. So it's like a human-induced stress, if you like. But it's not the answer to Varroa. I don't think we're over mollycoddling them either, but if we were, we'd take them away. Our friends in Wales have always said to us, we don't bother with any insulation at all, okay? And they've got the 16-year track record. And they live in Snowdonia. Actually, it's quite warm there. The Gulf Stream pops in. So they're out in their Bermuda shorts in January. He didn't tell me that. There was a question over there. Yes, sir.
There's a guy on YouTube, he's in the north of Canada, in the Yukon.
Oh yeah, I know him.
He
Yeah.
reckons his bees don't cluster until it's minus 35 degrees outside.
Yeah.
So I think we've been doing a lot of harm to our bees down to the years with little narrow walled hives.
Yeah. So a lot of harm for the bees by not insulating.
Yes, somebody told me it was somebody put a 35 watt bulb into a hive and decided then that the bees could survive, but it's, according to your friend Mitchell, that's a load of baloney.
Yeah, the more insulation, the less clustering they do. Is clustering a defence mechanism against the temperature? Probably. I mean, it seems to be. We have see-through crown boards which we use, and so you can see them clustering quite quickly underneath the insulation that we have on top. I don't know the real answer to it, but I think there's a simple principle that more insulation makes life easier for the bees, and longevity of the bees is good. If they don't have the Varroa resistant traits that we've talked about, they'll still die. They might die half a year later, but they'll still die. So having the traits is the key. Yes, Tom?
Do the workers cap and uncap the drone brood as well as the...
Yes. That's a good question. Do the workers uncap the drone brood and recap the drone brood? We see a little bit of it and other colleagues who have these bees see a little bit of it as well. And that the scientists say there's no evidence that they actually are pulling out drones with the Varroa inside. So Stephen Martin's done some work on this in Mexico and says that there's no evidence. Okay, so we have that bit of a beekeeper versus scientists debate on that. We think our most hygienic colonies, we do see it, okay, and in the book we have a picture of chewed out drone eyes. You know the drone eyes are different. They're big gog eyes. They're big pink purple-eyed gog eyes. So we know they've done it at the right time. So we think it happens a little bit. And I think that was from a colony which actually was completely on top of its Varroa load and uncapped just about every worker cell there was. So maybe it's at the more extreme end of Varroa-resistant traits, that once they're on top of it, they'll have a look at the drones as well. But it's not common.
Well then, on that, does that interfere or influence the overall picture of hygiene in the bees? Because the fact that they may or may not tackle the drone brood.
Yeah.
The drone brood, we were told, produces most of the mites.
Yeah. So the question is, does the fact that they don't tackle the drones, the hygienic behaviour in the drones, affect the health of the colony overall? We think not. Okay. If they're in the drones, they're not in the workers, and it's the workers which will see your bees through the spring, the summer, the autumn, and the winter. And the delta actually is, if they're successful at keeping the mite levels low, then in your drones you will have less mites in your drones. And if you have less mites in your drones, then those mites will be more likely to mate and pass on those Varroa-resistant traits. So there's a key natural selection delta there. So if we only have mites in drones, we don't have a problem, okay? We have Varroa-resistant bees, and that's what we look for. So this is, I thought we had talked quite a bit about what's happening. When what Samuel Ramsey found was that Varroa fed on the fat bodies, not the hemolymph. But actually, the reality is they feed on both. So there's been subsequent research to that. We didn't tell you how.
Since when?
I can't remember the date, but it's subsequent to Samuel Ramsey's original note. So there's been another bit of research which shows that they do feed a bit on both. Yeah. But the key thing is it's this vectoring of the virus, right? Yeah. So the vectoring of the virus in pupa is what reduces the longevity of these bees, which is why they don't get through the winter. That's the key to it. Right. So here's this is part of the monitoring for hygienic behaviour. So a green P is where the white skeleton, the exoskeleton we see, and the UN is uncapping that we see during the inspections. So here we are at the start of the year. Here's your pupa exoskeleton from this particular colony. So we already know that the Varroa have been taking on in January. So all the way through that winter, they're stopping the Varroa from breeding, and stopping them from breeding is why you don't get this massive build-up. And then when we start the inspections, we start seeing uncapping taking place. So we just take a note of those. A couple of points to point out. Here's your new queen, where she starts laying here, but she doesn't own the hive initially. It's going to take a couple of months before all her daughters take over. And so here we are in August with a lot of chewing out going on. These are the new daughters' nurse bees now, and a lot of uncapping, which is the last we see before inspections finishes, right the way up through that peak here. So the queen's daughter behaved exactly the same way as her mother, okay, which is why it's so simple. And then we saw less hygienic behaviour during the strongest part of the flow, which is the whole colony becoming a honey factory. And then you've got a bit of a sort of natural end of year brood break where you don't see the hygienic behaviour because there's no brood there. And then right at the end of the year, we're just seeing the start of the pupa again, which meant that those bees, the broodless period, finished probably around the middle of December in that particular case. So you know, there's all this sort of guesswork coming to you. There's all this guesswork about when the winter brood break is, but you know when you start monitoring, when you see that There's pupa exoskeleton that 2 weeks before your queen was laying, the brood break was before that. Yes, madam.
So I've started. Have not. Sorry, I've not treated my bees for 4 years, and they have always survived. They're all from one queen originally, and I have 3 hives now. And I read your book, and I'm looking for the exoskeleton at the moment, and I'm not unfortunately finding it. Although I'm hoping that my bees do have that trait. But what I do find is tiny little, looks like part of the wings maybe. Tiny little see-through.
That'd be wax scales.
No, but they're really see-through. They're not.
Now wax scales are see-through, and it's only when you put them together they have that sort of creamy yellowy hue to them.
So that can't be it.
No.
No. Okay.
You do find when we had someone came down from Sheffield, long day trip just to see the bees. We had the talk, we had discussion. He's the bee breeder up there for the whole area, and so he made a massive effort, came down. The weather was touch and go, but anyway, we had a break in the weather. We got down there, and I was trying to show him stuff on the boards, and I thought, where is it? You know, we looked in some hives, couldn't see much uncapping. But one of the problems we've got is that the mite levels are quite low in an awful lot of those colonies, so we don't see so much hygienic behaviour. So if your mite levels are really low over a period of time, that may be part of the answer. Then we did find it on one of them, so I sent him home happily on his 250 miles back journey north. And, right. So there's the full analysis back again, and again we've gone into a bit more detail in the book on this. We then went on to have a go at estimating what the mite levels would be on a sort of directional level through the course of the year, and trying to understand that based on that we knew what the mite drops were. So it's the green line, the green dotted line, that we're going to focus on. So we think it's a pretty even Stevens level playing field at the start of the year. We think the overwintered mites, which gradually are dying off because they only live for about 8 months, they've tried to reproduce here but not very successfully, because the mites have been taken on by the bees, and we know that because of the hygienic behaviour we're seeing. Then we think there's growth. At the time of the drones, we talked about the drones, less hygienic behaviour against the drones, and then we see a slight fall away. We know that because there was this blip here when there was an artificial swarm, and then we think there's quite strong growth in the face of the nectar flow. So, so very strong nectar flow here, less hygienic behaviour, colony becomes a honey factory, and then you get this peak, which is the fall away, which we see every year. And the size of that peak really indicates how much hygienic behaviour there's been already. So in a colony which, it peaked at around 25 a day, the mite drop, which was a bit scary, but I have a colleague whose peak drop per day was 150. And we sort of waved goodbye to that colony that winter, but she came sailing through the next spring and has been one of the most productive. It's quite remarkable. So, but generally a higher peak here and a higher amount of drop would indicate too many mites on your winter bees. Right? But don't worry if you see this peak. If you don't see a peak at all, maybe your monitoring's not up to scratch, and that's the time to worry. Yes, sir?
I've been keeping bees quite a long number of years, and I have never ever let that much of a chemical into my airframe. But I do a bit of drone removal. Should I stop? And we in Lake County Beekeepers never use chemicals, never ever. And we don't lose bees. We lose the odd hive.
To get Varroa.
But we do a bit of drone removal. Should we stop?
Absolutely, because you'll get even more Varroa resistance, because the drones which have got the least Varroa in them, because they're from the best, most Varroa resistant colonies, will be the healthiest, and those healthier drones will be the ones mating in your local area.
But we would go through the comb when we take it out, and we'll open them up and check 10 or 20. And like if we get Varroa mice in, say, hour 20, we get 12 with Varroa, we think we're doing great. Yeah. Are we doing bad?
No, it's you know, if the Varroa have all got into the drones, it's not going to give you a particularly good guide, I don't think, of what your mite infestation levels are. Because there's a migration of the mites from worker brood into the drone brood at that seasonal point in time. And there is, you know, in the UK they talk about 10% of the drones being infected as a key point to when you should treat, but then that's always their answer. I mean, I just think that's what you're doing, well done, you know, for not treating, and you've probably got Varroa resistance already. I think why don't you try some of your colonies and look for these traits?
Yeah, well, we never inspect, we just count the number of mice, we never go in to see exoskeletal bits, you know.
But you'll see them if you're looking at Mite.
Yeah, we never look for them, never knew they were there.
I know, well that's the stuff.
So
Maria.
I'm just interested in what that gentleman said, so they're not treating chemicals. Because I'm not a beekeeper, I'm sorry, are you happy with the Varroa level after not treating?
Oh, we have Varroa in every hive.
Okay.
We have Varroa, some Varroa.
Yeah, and you should. I mean, it's like having earwigs. I mean, it's not an issue if you've got a Varroa at a low level. You know, there's a question again. This is just a UK answer. There was work done in the 1990s, which came up with a Varroa Mite calculator, which was available for the NBU's bee base, which they've now taken down, which is a shame. And they came up with an answer that if there's 1,000 mites in your colony, you should treat. Now, the actual answer that the scientists who did the work came up with was that a normal colony size, or average colony size, could cope with 2,000 to 2,500 mites. But the NBU just slashed it in half and took it down a bit because they want to be conservative, because they don't want people to lose their bees, which is understandable. But there's your reality. In most colonies, they can cope with a couple of thousand mites, and that will be normal. If we just take you off somewhere else for a second, so in South Africa, where they don't even talk about Varroa anymore, not an issue, non-issue, they are now back to their pre-Varroa levels of winter losses. And winter's a slightly odd phrase for them, but it's back down to their normal levels of losses, you know, as if Varroa had never happened. And that's where we should be able to get to, as long as we all behave roughly the same way. That ain't going to happen. Okay. Right, so some evidence, again, we just try to look for evidence in our colonies for what really is going on. And this is in Hive 6, and we're going to look for uncapping and chewing out. So this is a piece of worker brood here on the 16th of May, and this is the same piece of worker brood 1 day later, 24 hours later. So can you see differences? So quite a lot of uncapping, obvious, easy, isn't it actually? One thing you can't see very clearly, there's a lot of recapping going on here as well. When you get your eye in, you can see cells that have been disturbed and recapped. We've got a few pictures in the book. We haven't gone on about it here. It's quite hard to see on the screen sometimes. But let's just put some colours on this. So this is in the 24 hours, so we know there's a lot of uncapping already, but this is the additional uncapping in the lime green colour over those 24 hours. And then the blue, we found one that's been recapped. That's these guys in the front here, thank you. We couldn't find another. If you can see another one, let me know. But that's in the process of being recapped, so that was fine. That pupa has been checked over here. And then there's quite a bit of chewing out that's gone on. And a lot of those cells were actually sealed. So, and it surprised the hell out of us when we took the pictures and started comparing them. We could not believe how much activity was going on. And this is in the dark of the hive. We had no idea. So no one's done this, and it's such a simple thing to do. You need to have a really healthy, well-behaved colony to do it on, and you shouldn't do it more than once, maybe in your lifetime, because it's not good for the bees. But from a point of view of research, or just confirming what you think is happening, or to demonstrate it yourself what is happening, we thought this was quite amazing, because we had no idea of that level of activity. And if we add on the first day's activity that we saw onto, including the recapping, the cells that was, so is there find a really obvious one that's recapped? It's not very obvious to see that one there. I think it's kind of darkish hole in the middle. There's your total activity on a worker brood frame. Wow. You know, we just had no idea, and this is going on in your hives as well, and that's That's the exciting part of this as we re-engage and start to understand it. So, at the risk of teaching you guys to suck eggs, I know there's a huge amount of expertise in the room already. This is how we produce our very resistant bees, our VRBs. So, in our breeding protocol, ideally you want 3 years. 3 winters is a good a time frame for having resistance where you've done nothing, you've not interfered with them at all. The second 2 parts of the breeding protocol are what we talked about, look for uncapping and shoot out infected pupae, and that gives you the low mite numbers which we talked about. And the low mite numbers corroborates that you have enough of the hygienic behaviour. Okay, so if your mite numbers are still going up, despite the fact you've seen some uncapping, then your bees do not have sufficient hygienic behaviour. And then you have to be careful not just to focus on a couple of things. So we've added in a bit of a catch-all here on number 4, spring health, which is that really strong brood health, strong brood growth that you should expect to see. A lot of foraging, the spring nectar and pollens flying in. And you know, if a colony in your apiary is not doing these things in spring, you know there's a bit of a problem, don't you? So you know they're not coping with this regime, or there's something else that's going on. So we keep an eye on that, and then gentle temperament, because we don't like being chased around the garden or watch. I've got a picture of my wife mowing the lawn with her bee suit on. You know, it was as close as ending the marriage as I can tell you. So that wasn't going to happen again. And then if you've got neighbours in the area or pets and stuff, you just have to be careful, don't you? So, and we talked about this being a really heritable trait, right? Which was such a find. That we just try and breed from our own bees. So you've got your honey production colonies here. We produce nukes. We use polynukes, and we use an incubator as well. So there's a few incubators around the club. So we have incredibly simple beekeeping that anyone can do. And then in the winter we're evaluating what we've got left. If there's any losses here, we can replace with the nukes, or we can sell them if we've got surplus. So we aim to be completely self-sufficient, so we do not have to buy bees into our area, which won't cope with our regime, and which probably won't have the same level of Varroa resistance. And we try to produce enough bees to sell to other people at non-commercial rates within the club area. So here's our nuke artificial swarm. So this is all we teach now. We used to teach the Payden with the Hayden extension method. That little funny board, I can never remember the name of it. Snellgrove board, thank you, sir. You know, what a crazy game that was, and chasing that around. And Demarys, which can be useful, you know, but I know everyone has their own ways of doing it. But we only teach this now, and this is all you need for the exams as well. So with our exams, so we just put the queen into the poly nuke. And it's one of those rare moments in beekeeping where you're actually in control of a situation. You know, it doesn't last very long, but you have a week of being in control. You know the swarm's not going to happen. So she's in there with a couple of frames of brood. The foragers, when they fly off, they all fly back. So you just end up with a nice little nuke, which you can dummy down and put somewhere else in the apiary. You've got the queen, you know she's brilliant at Varroa resistant stuff. And if this doesn't requeen, you can just put them back together going easy. Over here, this colony is producing the most beautiful queen cells for you. You're having to do nothing apart from just leave them alone and come back a week later. You know, so where did all this idea come from of reducing your queen cells down to 1? What a terrible waste of time that is, when they're producing beautiful, well-fed queens from a big constituency of nurse bees. So we come back in about a week's time and harvest those beautiful queen cells, and we pop them, and you can see that into these roller cages, into the incubator. And these are ones that have hatched. We lie those down already, and you just get this fantastic piping of queens as you pad around expectantly, like an expectant parent, and then you've got an easy source of virgin queens from your best Varroa-resistant hives. Piece of cake, right? Hardly any beekeeping involved, nothing clever about it, and these are bees' choice queens. Not us. We're not trying to pick out little larvae at certain times, and the youngest ones you can find, and try not to damage them and put them into an emergency situation. These are naturally produced queens, and we have found these so much better to anything else we've ever produced. We used to do grafting, and maybe we were just rubbish at it, but we used to find they were often superseded, if not in the first year, in the second year, even the second spring sometimes, and which was so disappointing, and we just thought, well, let's move away from that.
Sorry for stopping you there. Did you not find that that's because of the lack of drones in the area? Because that has been an issue there with the weather past 2 years.
Not here. These are our drones, okay? That's a whole frame of drones there, so all our best colonies get an extra frame, an empty frame of drones. So we try to influence the area, not just so we've got plenty of queen matings, but we want to influence what's going on. We know there's not an immediate benefit, it's a slight hit cost to the colony really, but we love them, and so we produce them like this, straight frame, no starter trip. We got a fat barbecue skewer down the middle, and they always make drones because we don't give them enough drone space, and so we think that we're producing a good product for them. So, which is natural wax. So there's no recycled miticides, which you get in foundation. It's the right size for them as well. They're not having to force drones into worker cells, and you know that all of the semen from drones is produced whilst before they're born in net wax. So make sure it's beautiful, right size and pure, and you will have a good supply of drones in your area. So we haven't really. You get unlucky sometimes with weather, don't you? When your virgins are out there and it's thunder and lightning, it's just terrible. That's Irish and English weather. So, but generally we don't have many troubles with getting matings. So, and we think we're doing a good thing in the area, and we have found our traits have really stabilised over the years. So initially they were a bit all over the place, and some were resistant, some were not. But now we rarely see a problem.
Sorry, when do you actually do the split? What time?
When they tell us to. So there's a lot of, I keep picking this up in Ireland, there's a lot of sort of almost by date beekeeping that goes on. Is that fair or?
Yes, it is.
Okay.
Well, they start in May. Mine start in May when you still do the queen cells. So that's when I find I have to carry out an artificial swarm.
So for us, we're just following what's going on with the colony. So last year we had a funny seasonal pattern of weather. It was it just threw us a bit, and we had some trying to swarm in June, and we had we had a couple of the normal time frame, which would have been early May, late April, early May. It just depends on how warm the spring is.
If you wait until you see queen cells.
Yeah, or it's just all the first charge cell, and then straight in there.
Okay.
And that's the only time we do beekeeping, really. The rest of the time we're just putting supers on and pretending.
Where do you put the drone frame for producing the drones?
On the outside of the brood nest. And then as the year goes by, we just put it to the outside. So it's usually full of ivy honey. If there's a crop of ivy honey coming in, it's right on the end of the frame. So they use it, which is what they do in the wild. So in the wild, they'll use those larger cells for nectar and honey storage, and then they'll use them for drones again seasonally.
Sorry, have you found, just as a observation, have you found that the pollen, let's talk about the last 3 years, the weather has been inconsistent. Have you found that the fact that the pollen coming in has been intermittent and has an effect on the bees, which might be a good thing or a bad thing? What's your analysis on that?
Yes, whether it's something that locally adapted bees have to cope with, but they do. So we find our bees turn on and off brood depending on the availability of pollen and nectar. So if there's if a flow finishes, so the blackberry for us is strong in the end, it's about second week of July, third week of July. When it finishes, we find that the colony can almost go queenless. And our junior beekeepers are going, "Oh, I need a new queen, what's going on?" But actually the colony's doing the right thing. If there's no income coming through the front door, they should back off the brood, because there's nothing they can do to feed it. And that's how bees behave. They don't feed from the stores, they feed from the front door. So local adaptation, I think, is just brilliant, and they actually do the right thing depending on what the weather's doing. This is sort of just a chart which sort of shows how we've got less mites over a period of time. And the blue one is this is mites over the whole year, a mite drop. This was back to 2020, so a bit further back into our project. So this was a not resistant colony in the end. There are too many mites in it, too many mites on the winter bees. And you can see here sort of a double scrape of mite drop coming down, so there are far too many mites there at the wrong time of the year. The yellow line was the hive one that we did the full analysis on. Okay, so that's a resistant colony. And then this is magenta line here. They had no truck with Varroa at all. They had the most hygienic approach to uncapping, almost too much so, okay? So, and there was no artificial swarm here either. So they didn't swarm, right? So there was no brood break mid-year. So the whole myth of brood breaks just went out the window for us there. It's all about this ability that bees have or not. And I would say most of our colonies now are sort of in between the yellow and the magenta line, you know, as a guide, but they've generally come down. So I've just got all my bees through for the second year, and I'll probably get wiped out next year, but it's, you know, you've got to celebrate your wins, haven't you? And we've had 2 very good years, and I think our bees are becoming tougher, more resilient, and the ability to look after themselves with obviously, clearly we were doing no good for them at all. So it's sort of...
So of the 2 lines, would you prefer the yellow one or the magenta?
Something in between. The yellow one would give me the EBGBs a little bit at this moment. So something in between would be perfect. And that's what we've got actually now, mostly. Yeah. But the yellow one would be fine. If you're seeing both the traits, the yellow one would be fine as well. You just have to get ready for this peak here and strap yourself in. So just being up front, we've had losses, okay? When we first started this project, we were petrified. Because like everyone, you know, you get told the same thing. If you don't treat, you're going to lose the lot. You know, and that's what we were trained with and brought up with. And we actually transitioned off the first year after a trip to Gormanston. Right. So this was when we actually saw Jamie Ellis, I think, this year. And the second year we met a guy called Dr. Ralph Buchler. He was down to do 4 days on Varroa, which seemed like 3 too many, you know, but by the third, we were cheering away, and he taught us these biotechnical methods, which we'll share with you, and it gave us this sort of courage to transition off miticides and just stop using them. And we'd used these, and we got 26 out of 28 colonies through, which we were cock-a-hoop about it, you know. As a sort of team leader, I had a one-way ticket to Rio ready, and we had a nervous first winter, and the bees, we had 2 queen issues, late supersedures, really annoying, that happens, and the bees not only survived, but they were bursting out of the crown boards, and so we thought, this is just really interesting, good news. So, and it was also a good weather winter, so we compare ourselves to the southeast losses in the BBKA. We don't know what else to do really, and it seems like a reasonable comparator. And the only year that we've been worse was this one here, which is your 3rd year. We keep coming back to 3 years of resistance is the key. And we got found out by a couple of colonies there. But the rest of the time we've outperformed what's going on in that area. So over the period of time we were about 5 percentage points better, which you know, we were thrilled to bits with it. We've now got a real good basis, a real good platform for breeding from and sharing other traits from. We've got some other data here from North West Wales. This is a massive area. There's now the 500 colonies in North West Wales, 16 years of not treating. They did a huge amount of admin work looking at treated colonies. So 2010, 2015. These were treated colonies in the Gwynedd region of North West Wales, and their loss rate was 19% for the treated colonies, and the not treated colonies were over that period was 13%. So that, again, interesting, no one knew what the outcome was going to be, but there's some logic to this. I think when you start producing bees which are resilient, look after themselves, cope with the Varroa themselves, they should be tougher. You know, we're not keeping the wrong ones alive, which is what we've talked a bit about today. Working as a club. So there's a few different clubs here. We found this a brilliant way of moving forward, and there are a number of different clubs who've got projects going now. So we set up ourselves a breeding apiary. People keep asking us for bees, and we've focused on giving bees internally to try and fill out our patch, which is quite a big one. So, but we've now set up a breeding apiary. It's new. So last year we were clearing brambles and, you know, all the ugly stuff, and we've put some of our best traits have gone into it. There's also a feral colony 50 metres away, which we like to see. So it should be able to, and we're going to grow that out to 15, 20 colonies, you know, things go okay this year. So we should be able to produce a lot more bees. That was one way of doing it. And it avoids club members bringing in colonies from outside, bought bees in, which are often based on imports, which we don't want to see in our area. Here's a schematic of it, just passing queen cells, queens, nukes around. It's easy to do, and WhatsApp groups are just simple ways of working together. You know, beekeepers like helping each other out, and the answer is usually a bottle of wine and a thank you, and that works. And what goes around comes around. We all need a hand sometimes, don't we? And the people you've helped are always going to help you back. Here's a club project set up next to us. Reigate Beekeepers, one of the biggest clubs in the UK. And it's a relatively new project. They've got WBCs and polynukes. And what they've done is to put their best traits from what we've been talking about today into this apiary. They found one colony that didn't have it, which was a swarm they picked up where the mites were low, and that's gone off to their treatment apiary, which is about 30 miles away. So they got rid of it pretty quickly, and they set themselves up on the map here. This is them in purple, right next to us here in yellow. Which some sense of that, really, isn't it? Yeah, but of course, they're going to help us as well. We can help them, they can help us. It's all good, you know. And we'll share hopefully some of those resistant colonies. So working together with local beekeepers has worked well. With another example here, Central Sussex, which are just south of us, closer to Gatwick, and we went and saw them. We saw them a bit last year. We went and saw them in January, and they set up a 21-member WhatsApp group this January, and they were all excited, sharing pictures of their Varroa boards in which they put in, and here it is. They've got bits of pupal exoskeleton. The excitement, you could feel it within the club. I'm on their WhatsApp group, just sort of monitoring and helping a bit. And this lady here, this is like 4 days after they set it up. She hasn't treated for 3 years. No one knew that. And she actually got her bees during lockdown from the chair. And he's got pupal bits on his boards as well. So they've got Varroa-resistant bees they never knew they had. And they can't wait for the season to start, you know. And this lady called Pip, she's now everyone's best friend in the club. Took them a couple of weeks. So in the winter, you can be finding your Varroa-resistant bees. You know, your beekeeping. If you want to re-engage, you know, it's easy to do. A few lessons learned, okay? So not everything goes well in beekeeping, as we know. And so these are some of the things that we learned, and hopefully will shortcut your own experiences. So we spent a lot of time staring at mites, which are dropped to the bottom wall, which had bits missing, bits of carapace, antennae, legs, and cheering every one of them. I thought, this is great, isn't it? You know, and we'd read everywhere that grooming was really important, and this was research had come out of Asia, and we just accepted it as the scientists without really challenging it. So we like to sort of try and do a bit of our own work, but what we couldn't understand was this. But this is from a colony, High 5. There it is. This is the total mite drop for that full year of High 5 in 2020. 3,200 mites. Wow. Okay, so that's a non-resistant colony. That was the one we showed you in that graph a minute ago. Right, that didn't survive that winter. And about a quarter of all the mites were chewed on from that colony. But obviously no correlation with grooming and mutilation. So what do you think was going on? Mites eating one another. Okay, interesting, yeah. Any other ideas?
Mite loads are so high that even the mites can't hide. They're just dead in the open.
Yeah.
So that's why there's more of the grooming going on.
Yeah,
It's
okay.
not too high, so it's expressing itself.
Yeah, and we think that's right. We think it's actually, there's so many mites in there that when the bees go and chew them out, whether they're chewing out a dead pupa, you know, because it hasn't worked, or whether they're trying to do Varroa-resistant stuff, when they grab those soft-bodied mites, they damage them with their mandibles. And then they let them go. They go to the floor, and then we jump up and down with excitement, shouting grooming and mutilation. But actually, the reality is there's no correlation at all. Now, we looked into that a bit more. Something we took to Stephen Martin, who is like a global consultant in a way. He's been around so many Varroa-resistant colonies around the world. And he got one of his ex-students to do some work, and she looked at, this is Isabel Grindrod, she looked at the original grooming report that came out from Asia that everyone has copied, and it was from a guy called Ping in 1987, and it's been copied all over the world. And what they did was, when you're going to test for grooming, you need some mites. And what they did, they grew these mites in a colony of Apis mellifera bees, which had no defences, so there are tons and tons of mites in there. And then they put the mites into this Apis cerana, so Asian honeybee colony. And the bees were grimming like mad and biting and everything else. And then that got reported on. Now, the thing about mites is within about 2 hours, they can take on the smell of their host. They take on the hydrocarbons and they have this chemical camouflage, so you cannot smell them in the hive, which is an important problem for the bees, or good camouflage for the mites. You might be able to sense them and they're feeling them, but you can't smell them. But if you take Apis mellifera mites and put them into Apis cerana bees, they can smell them. All right, so the whole idea, the whole assay was wrong. It was badly set up, and they jumped to the wrong conclusion and told everyone. We think that grooming probably has a small role, but it's not something that you need to select for, and you don't need to monitor for. But you won't hear that from other people. You will hear that grooming is part of it, and you hear that from it's much easier to tell you that grooming is part of row resistance. We think if it's a role, it's a really small role. Not treating for 3 years, we talked about this 3 years thing. Keep the champagne on ice for your second year, don't tell too many people, and then cork it into your third spring. So here's the green line, which is our bees, and other people have got them here as well. Roughly at the end of the year, your mite level should be about the same as they were at the start of the year. Otherwise, if it's higher, then the bees have a starting platform which is high. So you get this build-up year after year, which you can see in the purple line. And there's a colony that comes under risk, that the default wing virus per bee goes up, and at these levels the colony can't survive. There's longevity, gets brought back by about 2/3. So often they'll be dead by Christmas, or if they're lucky, will make it to January, February. But initially, you haven't treated for 1 year, and you are proudly telling everyone, just keep it under your hat, okay? Keep an eye on your mite levels, and just see how you're going. So 3 years is a very good test, unless you're really seeing this behaviour and those other. So we're now more confident to be able to recognise the traits and can go into a hive and say, look, this looks really good, show me your background of your mite levels, and you can spot them more confidently, I think. So we'd be better at doing it now, but 3 years is a good test. Be wary of swarms. Well, everyone likes free bees, don't they? And this is never a very popular message, but capturing local swarms, unless you know they are from long-term feral colonies, always be the first there to get those. But you might just be taking in mite-susceptible bees, which are going to dilute your traits in your own apiary. That's the last thing you know. We've been breeding these wrong bees for a long, long time now, so be wary. You can test for row-resistant traits, in the first of your sealed brood, worker brood, have a look for uncapping and chewing out, so you can see that early days. You can use those bees to requeen, if you have some queens or an ability to requeen, or take the queen out and then take down any queen cells and then give them a frame of eggs and larvae from your best row-resistant colonies. Or you can give them away to someone else, to the training apiary, out of area, somewhere a long way away, for someone else to terrorise and play with, once you know they're happy, healthy bees. So just be cautious is our approach to swarms. I've not taken any swarms into my apiary, and because I produce a small surplus every year of bees, and I don't need to take the risk, because we know that the bees, the heritability is so high from the queen lands that we don't need to bring in new untested colonies. This is a bit of a UK moan, okay? We have a lot of imports coming in, including from some areas, not too far from where Tropiolaelaps has been found, all right? So, which is out here somewhere. And last year it was just under 10,000, possibly was higher. There's some backdoor queens, I think, coming through Northern Ireland. We don't like them because they're narrowly bred, okay? And bees aren't made to be narrowly bred. They're made to have wide, diverse genetic resources in that spermatheca, and so we don't see them breeding true, and we don't see them as resistant bees. So we don't accept them into our area. If we can do anything else to keep them out, we do, and particularly we want to produce more and more of our own local bees so that people, our club members, don't have to buy them in. The other thing, interestingly, and I hope this isn't true in Ireland, in the UK there's been a real loss of breeding expertise, that all the high-profile sellers of queens and nukes bought these bees in from different parts of Europe, and so they don't breed any bees, so they're just raising queens and nukes from what they brought in. So a complete decimation of expertise, which is a dreadful shame, and I think that will change when the education on beekeepers grows, where we start asking the right questions. And the questions that we're asking is, firstly, are your bees treated? Which is always a clue to whether they, to number 3 really, do they exhibit any Varroa resistant traits? And you hear the jaw dropping, you know, when either the email, metaphorically, or of your conversation, and people get quite defensive about it, but the breeders will have to change, okay, because buying non-resistant bees is buying a massive problem for you. You're buying mite breeding and virus production, and it's the last thing that you need. So that will change, I think, quite quickly in the UK, and I suspect in a lot of other places as well. And then we also ask whether your bees are based on imports, just again as some extra clues. So we're looking for a bit more transparency, and there's going to be quite a bit more publicity on this, starting soonish. So we don't want to kill off anyone's business. You know, people have got a right to survive in beekeeping and make a living out of it and all the rest of it, but we do want to see some change as well. So putting out a problem product is not a good thing for beekeepers. And I'm playing to the audience a little bit here, or some of the audience I suspect. Our bees have got darker with open mating and with Varroa resistance. So here's one of our founder members, Topsy Rudd's queen. She used to fondly call it Blondie. You know, she was really in love with Blondie, and you could always find Blondie. Didn't even need to mark it really, because she just pad around in a big yellow flag of an abdomen. And here's the same colony in that 5-year cycle later. Very dark. Everything's darkened up. Now we have a lot of hybridization still, okay, because that's the southeast of England, I'm afraid. But think that the bees have got darker generally across everyone who's had these Varroa resistant bees with open mating for the last 7 seasons. Note of caution, there's a huge amount of mite susceptible bees out there, okay? We've been breeding them for a long time, so just be careful. Don't just stop treating, because it's not cool to do that. I think it's just look for the traits that we've talked about, monitor, be selective, and do it gradually. Just do it cautiously, and that makes sense to us, and enjoy your beekeeping at the same time. You know, do the right thing, but enjoy your beekeeping. If you're new to beekeeping, we find an awful lot of enthusiasm to do this, but actually it's probably better to just learn your bee craft first. You know, we all remember back with a sigh about some of the things that we did in our early years, and perhaps wish we hadn't, but there's a lot of judgment in beekeeping, isn't it? And when you first start, it's pretty hard unless you've got a fantastic mentor. So this may not be for you unless you've got a fantastic access to some brilliant bees, and there's usually someone who puts their hands up and says, you know, we're doing it already, you know. But anyway, but be careful in your early years. And I say minimum 3 to 5 colonies is quite a good guide, right? But you know, up to beekeepers. But just be a bit cautious. This was our cautious first year. This is what we learned from Ralph Buchler. We replaced this late summer treatments with what's called a queen frame trap. I don't know if people know them, we use them a lot in Germany, which was the most efficient way of removing Varroa I've ever come across. There was hardly any Varroa in the hives after that. And I remember emailing Ralph saying, can this be right? And he wrote back with just 2 words, German efficiency. and they are incredible at actually taking out Varroa. And the other thing he taught us was brood removal, which is a bit ugly. It's like a shock swarm. And you take out all of the brood in middle of August, and you replace it with drawn comb. So you need a supply of drawn comb, and then the queen will lay up all of the drawn comb with your winter bees, and most of the Varroa will be in that brood which you've just taken away. So you've taken away 80% of the Varroa, and you're feeding it to the chickens. it's not a nice thing to do really, but it doesn't come naturally to beekeepers. But as a bigger problem than that is that we were taking the Varroa problem away from the bees, and we realised that. So this helped us get through the first year of getting over that mental hurdle of if you don't treat, your bees are going to die, which it did. But we then moved on from that to bees only and started making selections because they were so good. That's just replaced. It was a very efficient way of replacing the summer treatments. But that's all we were doing. We were probably keeping the wrong bees alive still. But the big win, again, we were just muddling along, learning on the job, was not treating in the winter. And the benefit of that was that you leave your bees and your Varroa to try and get on for about 6 months through to the following spring. And that's when you find out the following spring how your bees are coping with Varroa or not. And that's when you can make good decisions on which bees to go forward with and which ones not to. So stopping the winter treatments is a good way to start. All right. Here's the wrap up on getting started. Be cautious, look for your VR winners, look for the traits that we've talked about, work as a group if you can. We agreed to underwrite our losses within the 7 of us, so that if we have a disaster, whoever doesn't have a disaster will help out, okay? And in that way, we were sharing the best, or we're replacing the worst of the genetics with the best, if you like, simplistically. Raise your own queens. We call it genetic gold, the locally adapted bees. You're not going to get any better, are you? And they're a right old mix of all sorts, because we've been importing for 170 years or whatever it is. But they have got darker, but they're good. They're right for our local flora. They stop and start when the flows stop and start, and they're right for our local microclimate. So that works very well. And if you can source from your new best friend who's got very resistant bees, got a heritage in them already, that saves you a lot of time. Or get hold of bees from feral or unmanaged colonies somewhere. We all sort of know that there's some knocking around, so try and sneak up a bait hive somewhere. We're having some help now, which is really good. We've had a laborious amount of discussions with the RCBKA, which is our sort of main teaching education organisation in the UK. And they've now included Varroa resistance in the modules. So if you want to become a master beekeeper into your modules, you now have to understand it. So there's a huge benefit there going forward. And all the teachers of this have to understand it as well. And that will filter through also to the practical exams. So big win, I think, in terms of understanding Varroa resistance for everyone. So that's a really good change, and that's from this November. People in our club who are taking modules 3, 6 and 7, I've told them to make sure they have to pass them so they don't have to learn this stuff. So we'll see how that filters through. The other big change has been, I would say, call it our third organisation, Bibber, if you like. And we have a bit of Bibber in Ireland. I know we've had Bibber come to some of the Bibber, so people from Ireland come from the Bibber conference we had in Carmarthen. They're just about to champion Varroa resistance. So they're really going to go high profile, okay, and they're really going to go for it with enthusiasm and clarity, and there's a bunch of us helping and working with them. So there's going to be a lot of new material coming out of them and encourage them. So Bibber is about bee improvement, so this is the biggest area of bee improvement in 30 years, I would say, for everyone. So selecting for the Varroa resistant traits is actually really quite straightforward. That's the queen with the magenta chart, with the hardly any Varroa in the hive. I mean, she's not the prettiest at all, but she was incredible against Varroa. But the pace of change is really up to beekeepers. You know, if you pick this up and start doing it, we'll get over Varroa really quickly. If we start asking our bee suppliers for Varroa resistant bees, we'll change things very quickly. And there's a huge amount of information on the website we talked about. We have a book here with a lot of stuff in as well. And there's going to be other projects, not just UK, but across Europe in Scandinavia's projects. There's this Varroa Resistance 2033 project, which is kicking off. It's going to happen at the CCAM conference next week. There's bits on Varroa, which is European AMM, Apis mellifera, so not Irish, but close enough. So it's happening all over the place, and it's going to happen quite rapidly, I think. There's our little book. We had a super and very gracious review from Tom Seeley, who's been very supportive of all the efforts towards Varroa resistance. And we're also supporting Bees for Development, so all the proceeds of the book, less the costs, putting it together, going to some good causes out in Africa. Thank you very much for your attention. Thank you for your Q&As.
Okay, we've had 2 hours, and that was a fantastic lecture. We all enjoyed it. I hope you can hear me, or can't hear me. And Steve has got his book here. He's selling it for €20, I think, and it's €8 goes to Bees for Development. And just an answer to your question there, the native Irish honeybee actually, a lot of them don't treat, and particularly Alan Oshcroft down in Tipperary, they don't treat. So it is the direction of travel, even though I'm a self-confessed addict, unfortunately, and I'm not going to go cold turkey. It'll probably be, as we say, and I said my friend there, Jerry O'Brien, is to say, it'll probably take us a few years, but the direction of travel for us has to be non-treatment, like what you're saying, and like with our friends here. And where are you, Cavan?
No, Mullingar.
No, I have to be your best friend now.